Welcome to Software Snack Bites. I'm your host, Shomik of Bold Start Ventures, where we partner with dev first and SaaS founders from the first line of code. Today, we're excited to have Chris Huskey on the pod. Chris is a partner at Octahedron Capital, a crossover hedge fund investing across the public and private markets. And in this episode, we're doing a deep dive into all things Databricks, covering the company's story from end to end. So Chris, I guess to just jump right in, what is Databricks? Who are the founders? Kind of describe their story and how Databricks started.
There was a Forbes article not too long ago, maybe 12, 18 months back, called Accidental Billionaires about this founding group, because they really have a very unique founding story. While they're very commercial and commercially oriented now, and they're all still at Databricks, there were 7 co-founders of this company. They all came from academia. And originally, they were not as commercially minded as they were now. Originally, this was really a research project. And this team is particularly notable because it's arguably the best or one of the best distributed systems teams coming out of academia in the past 10, 15 years, if not longer, especially building a lot of the distributed systems architecture and infrastructure that now underlies everything you do if you're a data scientist, an ML engineer, an AI engineer at a Wayfair, at Uber, et cetera. So back when they were at Berkeley, in a couple key teams, a small few people at Amp Lab that produced an inordinate portion of the key data infrastructure that all of us are using today.
It's crazy, yeah.
Mainly under Professor Ion Stoica, who's a Databricks co-founder, and Professor Scott Schenker, who's on their board. Produced a whole bunch of things. The biggest is Apache Spark, which is arguably the most used single project in the AI and ML and data science world. If you're at Wayfair, all of your ELT and a lot of your data work getting into your systems is with Spark, and similar with almost everybody. Anything to do with large amounts of data, you're usually using Spark for a whole bunch of things throughout. And that was created initially by Databricks co-founder Matei Zaharia, who is an absolute superstar among others, but also part of their Series A story is that Scott Schenker, professor there, gave feedback to Ben Horowitz, who was making the decision at the time, that Matei Zaharia was one of the best distributed systems people to come out of academia in over a decade, which is absolutely true. Main creator of Apache Spark, alongside some of the other Databricks co-founders of Apache Mesos, which a few years ago was competing with Kubernetes. There's a lot of overlap there to become kind of the container orchestration platform of the future. Tachyon, which became Alluxio. Also out of that team, Apache Ray for AI/ML applications, and then all the things that came out of Databricks itself. So evolutions of Spark and Delta Lake for your Lakehouse, all of these things that are some of the top projects in the entire data science, machine learning, and AI world today. So phenomenal team coming from that background, founded the company, initially research project, learned all the commercial side, scaled rapidly, and turned these what are still some of the leading open source projects in this whole data world into massive commercial products today.
What an incredible, just an incredible story, an incredible group of teams. Also that transition, frankly, from academia to now very commercially minded, executing well on all of that is also just a testament to them being able to learn at such a rapid scale. So really an amazing team. Before we dive into things further, just for the listeners, what is Databricks?
I think there are a couple big pieces that we'll weave through everything we talk about today. And we'll get into some more detail on these in a second. But essentially what they're going after from a customer's point of view, if I'm a CIO, is they provide 2 major things. One is everything that revolves around Databricks Lakehouse, which is many different layers. And what that is basically your company's core data infrastructure for everything on the analytical side. So this is the OLAP side of the world, not the OLTP side of the world. Or at least not yet. We have Snowflake
Right.
Unistore on the horizon. In a few years, we'll see where both of these companies go. They're both expanding at a rapid rate. So that's number one, is your entire core analytical data infrastructure. Powering everything you do, going up to business analysts, SQL queries and analysis and dashboards, as well as the entire AI and machine learning side, which used to be wholly separate. And even Snowflake is working on bringing these together. Databricks combines both of these so I can work with raw audio files and video files that I'm analyzing in an ML model or a neural network off my data lake, but at the same time, business data sitting in something closer to my data warehouse. So this is Databricks Lakehouse. Big piece number 2 is actually their original business, which when we first invested around 3 years ago was basically the entire business. Now Lakehouse is growing extremely rapidly. But this is what I'd call their entire Databricks workspace for AI and machine learning and data science work. And if you step further back and are a little less in the weeds on this, you can kind of think of this as if you're in the finance or old school tiny data world, you do tons of stuff in, say, Microsoft Excel, or at least 10, 20 years ago. Everything was there. It has all these functionalities in terms of functions built in. You can write Visual Basic. It has actually some data models. It has all your connections to all sorts of different databases, and it sits on top of your storage and data management layer, which is your computer usually back then, and your file system. Databricks, but Excel or Microsoft Word is kind of where you go to do every type of work with data 20 years ago, right? Databricks is like that for every type of AI, machine learning, data science work, including a lot in the new LLM era, right? When I'm actually fine-tuning an LLM or connecting a trauma or something, I'm actually doing that in a Databricks notebook. And so what that is a comprehensive workspace that manages everything you need to do on a day basis. It's got your notebooks where you're writing your code, you're running tests, you're training your models, it connects to your databases, and it has all these surrounding major functionalities used by tens or hundreds of millions of people. For example, MLflow for all of your tracking, all the experiments, if you're running a neural network and training it, all the experiments you ran and what the different values started and ended as, what hyperparameters you put in, and then what the end weights were across many experiments and finding the best one. So all these things you do, other things like feature store, et cetera, throughout everything you do, a few dozen things in your day-to-day machine learning work. It's a comprehensive workspace that abstracts a lot of that complexity away and saves time on doing all of that day-to-day work.
Got it. What is kind of like the sense of the scale? How big is Databricks? I mean, kind of whatever is publicly disclosed, I guess, but like how big is the company? Give us a sense of the scale.
So they shared a few things recently around their Series I fundraise, which is kind of a pre-IPO round if you look into the specifics, and led by T. Rowe Price with participation from NVIDIA and us as well. And what they shared, they have 10,000 plus customers. They passed 1.5 billion in annualized revenue run rate in Q2, and that's growing over 50%. And we actually think there's a very good chance, based on a lot of our customer interviews and such, that is going to accelerate into the second half of the year. So materially faster than any of the competitors right now. And they have 85% plus subscription GMs, gross margins on a non-GAAP basis. Basically best in class for everything. Of course, profitability, they're a little bit behind where, for example, Snowflake is today because they're reinvesting aggressively. But for example, they talked about their expansion and retention. And through the end of last year, that was 150+% net retention rate. So phenomenal metrics across the board.
That's about as good as you can ask for. So can't get much better than that. Yeah. Whenever you hear Databricks, you brought it up, right? You mentioned Spark, and the founders of Spark and the core maintainers of Spark are co-founders of Databricks. And so I guess the question would be, what is Spark and why is that kind of associated with Databricks besides obviously the founding team?
Spark is essentially where it all really began. You can give them a lot of credit for all these amazing, literally industry shaping open source projects. Even Apache Mesos was a huge deal for many years and shaped a lot of what's happening with Kubernetes and others now. But Spark was the really huge one and is the most used one today. So Mate, as well as CEO Ali Godsi and some of their other co-founders, Reynolds Sheen, they were all involved in creating Spark and building it into the massive project it is today. And what Spark is, the headline is it's called an execution or engine or a query engine. And what it's built for is, if we kind of take a step back, Hadoop has maybe become a bit of a dirty word among at least CIOs today. But a lot of the ideas that began in the Hadoop ecosystem and the HDFS and Impala era were around, previously people didn't work with massive amounts of data, but as you had the Instacarts and the Ubers and the Lyfts and Netflixes, storing a whole lot more data in real time in many cases on what I'm doing as a user regularly every day, every second, and then trying to work with all of it and predict things, train ML models on it, et cetera. You have to have infrastructure capable of supporting massive levels of data, right? And so with Hadoop, you were using a lot of the traditional thinking around the MapReduce approach and basically saying, we can't put this all in one place. It'll be too slow and cause all sorts of problems. And we'll have to wait 2 weeks for our model to train, right? Instead, we'll set up distributed systems across many servers and spread out. Depending on the way you're using it, this often means splitting the data. For example, in training a new neural network, you actually use some of these ideas later on, which is mini batches and splitting your data into different places and such. And so in that whole era, all of the infrastructure was built for that. And a lot of the cutting edge stuff we see now from Databricks, Snowflake, and some of these others is actually some of those initial ideas and ways of thinking just in version 5 and dramatically better in a way that they are impacting the entire data world now. And so Spark was kind of the first big realization of a lot of the initial hopes and dreams of the Hadoop world, which is if I've got my data stored in all these different places across many different servers, right? Sometimes in a less organized fashion, how am I going to be able to pull the data I want at any given time, query across it, clean it up and prep it and transform it, all these things without spending my entire life on data engineering? And so that's what everyone uses Spark for initially, is a lot of the ELT work, right? Pulling data from all the different places and running the different processes, anything I need to do on cleaning, transformation, getting it to where I can work with it with my model. And so that's where the entire company started.
We just talked a lot about data and cluster management, all these sort of things. So I guess like when you're talking with customers, who are the personas that use it? Is it, a software engineer? Is it an ML engineer? Like kind of who are the types of personas that use it?
Definitely. And it's changing pretty rapidly. When we first got involved with Databricks and first invested about 3 years ago, and certainly in the years before that, Databricks was really a bottom-up go-to-market in that it was more organically adopted by developers. Somebody like even we use it at Octahedron. We're doing our time series analyses on finance data and such in a Databricks notebook, right? So the first catalyst that really got it going was a lot of the people like the Wayfairs of the world, that a few are able to build all of this themselves, but the vast majority aren't. It's a little like Kafka and Confluent's case, that if you actually try and work with raw Spark open source, you have to know what you're doing, and you're going to have to spend a lot of time fixing things and lining things up. And when things stop working, there are all sorts of problems in maintaining this entire distributed system. So Databricks provided runtime environments, basically, that made Spark extremely easy to use and all of your machine learning day-to-day work easy to use. So what that meant is you click or write a command line command, and quickly you have a Spark cluster running with everything set up. If you need GPUs on a few different instances, you can do that, right? Or you can just have this live and ongoing. So it was the commercial version of Spark. And that from 2014 to 2017 was the first huge wave of uptake. This was all data science teams and ML engineers and such. What's happened since then is they launched this entire Lakehouse core analytical data infrastructure piece, which started with then those data science teams using Databricks Workspace. Instead of working with BigQuery or Snowflake, which has other back then problems and is harder to work with raw audio files and unstructured data and such, we'll use Databricks Lakehouse for more things. Then that spreads to more teams, and then a CIO buys it for an entire department or entire company, often competing with Snowflake. And so it's evolved rapidly since that. And on top of Lakehouse, the big newer piece in the past year or two is called Databricks SQL, which is essentially competing to converge over time with Snowflake and compete directly. And this is what were initially Snowflake's core customers, your business analysts writing some basic SQL queries to send create a dashboard for your sales team or your CEO type. So it's expanding rapidly, and we're seeing phenomenal uptake there in the past 12 months, especially, where it took a couple of years to get going.
What are a couple of case studies? I mean, you mentioned some customers already, like Wayfair and others. So maybe you can, whatever one you want to bring to life, maybe just one of them, how did they use Databricks to accomplish tasks that kind of drive their business forward?
Yeah, it's extremely wide ranging, and you see all types from a very high level, from healthcare companies working with genomics data in Databricks Lakehouse, but maybe it's not as perfectly structured, and so you want it in your data lake, then going through Databricks Lakehouse, and your machine learning team tries and runs some prediction models off of your data set there. To a lot of financial services customers using Databricks for often Lakehouse as their core data infrastructure, and then their ML team using the workspace to train models for credit card fraud prediction, for example. So Capital One is one example here, which interestingly was also Snowflake's biggest early customer. But they're using it for a bunch of things on their credit card fraud detection and prevention side. So when your or my credit card gets stopped on the way to a transaction or wire transfer, then often that's going through their system. And it goes from there to a number of others. Starbucks uses it for demand forecasting in a number of areas, what customers will buy, both online and offline. And you have many different examples.
Was there a kind of singular moment that really kickstarted or accelerated Databricks growth forward? And I think you did mention, the first few years was kind of powered by Spark, right? And that being the key driver. And so maybe that's just like, hey, ML workflows were exploding at that time, and that was a driver there. And then it sounds like maybe Lakehouse was the second one or something. But I don't know. I don't want to put words in your mouth. Like, what do you think are some of those kind of really key moments? Like, boom, this happened and it really accelerated things.
The big one more recently was everything that came around Databricks Lakehouse and that entire massive new market that they opened up. That's actually pretty new. The project really got going in 2019 in the Data Lake project, which is now in the Linux Foundation. And Lakehouse really was a 2021 and beyond story.
I got to say, hats off to Databricks marketing team. Now I'm like, oh, Lakehouse. Like I've been brainwashed into thinking about Lakehouse when I think about Databricks.
Absolutely. This word and this category wasn't a thing before them, but then you hear Snowflake and Google and Cloud and everybody talking about Lakehouse, Amazon saying they're offering a Lakehouse. And everyone's really moving in that direction. Snowflake and Databricks are converging, and everyone's realizing you have to have a place where you can. The big problem they were initially solving with a lot of this is, at least in the US, you have this 20 plus year legacy of data warehouses, on-prem data warehouses and such, right? Where sure, that was good for your business data, but people were having to build this entire redundant data infrastructure for your AI and machine learning work off your data lake. And so now Databricks Lakehouse combines all of this into one comprehensive whole with your governance layer on top, which they also own, et cetera. And that makes it much less redundant, much more cost efficient, all of this. And now Snowflake, BigQuery, they're all moving in this direction coming from the other side.
If we go into the platform a little bit deeper, like what are the main product components? You described the two, sort of the notebook and the Lakehouse. But if you were to just kind of generally say, like you mentioned Delta Lake, right? That's their Lakehouse. Kind of what are some of those main product components that people should understand?
The first is anything in that data science workspace. Any work you do there, the big thing there is they manage the runtimes. You can set up a Spark cluster, you can have one running, all sorts of things, or you can have GPU instances for larger models, larger language models you want to train, anything you need there. They also have all the surrounding stuff. So model versioning and ML flow and tracking. They have a model registry, feature store, all the things you need to make your machine learning and AI work enterprise scale. The bigger one of the past couple of years is Lakehouse and Delta Lake and all of this. And what this is really coming from is each of these massive products that's serving multi-billion dollar or multi-tens of billion dollar TAMs actually came up really organically in Databricks' case, right? Spark, they initially built to solve all the problems they were facing they were running AI ML models and finding they had to spend all their time on data engineering, and everyone else did too. And so they built this system that now saved tons of time for everybody. Delta Lake and Lakehouse similarly came out of a lot of problems that everyone in the industry was facing. As you started working with really big data, your Netflix, your Uber, your Wayfair, your all these companies, at that time, you couldn't just work with a traditional Oracle solution or Teradata on-prem data warehouse. It just didn't work with all the unstructured data. So they all built their own solutions. And now Databricks is offering that as a wider scale commercial offering, basically. But people had all these, what's called a Lambda architecture back in the day, where they had just basically tons of redundancy. Lambda was, you had a redundant entire separate path basically for data real-time streaming and analytics off of that. And then you had a whole separate path for storing data in your data warehouse and working with business data that went to your BI and your AI ML team. And all this was just being maintained ad hoc. So people were wasting all their time on data engineering work if they weren't a data engineer. And so Delta Lake and Lakehouse was huge because it builds a few layers that your entire storage and management layer, turning your data that's in your data lake into a fully functional data warehouse and lakehouse type of setup that manages upserts, inserts, all of this in an ACID compliant way, if you think about databases that you can use for commercial products. And the next big piece on top of that is that they built a lot of functionality around real-time streaming, as well as the latest big piece is this data warehouse competitor, basically, which is called Databricks SQL. And that's serving the whole other side of the market, business analysts.
Got it. Yeah, that's almost moving into the BI type use cases that people need it for. So all these products are getting added on, right? It's expanding. Databricks is expanding in a number of different ways. Do you have a sense for what's still the main driver of kind of initial lands? Like, is it now, mostly Lakehouse? Is it still kind of those Spark ML use cases? Like, do you have a sense for that?
Yeah, it's shifting really rapidly. If you were to go back, say 3 years, often you were certainly 2017, 18, it was always still managed Spark. We're using Spark at massive scale at Netflix, for example, and we just want to abstract away a lot of the complexity. You guys optimize this to the absolute utmost on cost, on setting up clusters, on all of this. So we'll do that. A couple of years later, 2018, 19, it was for the broader data science workspace, but still data scientists coming in and getting it for their whole team. Now it's shifting quite a lot. So 2021, 2022, you started to see a mix where, yes, they were buying the data science workspace for their team because they loved it, but they probably also started with some level of Lakehouse usage, just because they wanted to work with data in their unstructured data in their data lake and run all these AI analyses. Now we're seeing, really in the past 3 years, Databricks used to be this bottom-up go-to-market. Really, people were adopting it within the company, and then it spread between teams because it was so good. People kept recommending it, then to their department head and et cetera. Now they've built this very strong world-class top-down go-to-market. So we do actually, really in the past 18 months, especially in this LLM hype era, which this infrastructure is made perfectly for. It's completely tailor-made for. Now we see all these CIOs and CEOs sitting down and saying, should we, from the beginning, move our entire data architecture for our company or our department or this new greenfield project straight to Lakehouse? So now we're seeing all of it bought at once much more often than we used to, and it's moving in that direction.
I want to move into the market, which there's going to be some fun questions here that I think a lot of people are thinking about. But before we do that, first, I guess, how do you come by a TAM analysis for Databricks, right? Clearly it's very large, but just, kind of, if you were to just riff on that, what would that be?
Definitely. And we'll have to keep it super high level. I think the big pieces that matter when you think about it are, first, the entire core, essentially OLAP market, the analytical data infrastructure. There are two sides of the world, the transactional OLTP side. That's about 50 going to 55 billion, including cloud and non-cloud, right? The analytical piece is closer to about 35 billion, including cloud and non-cloud. And we think all of that is ultimately capturable, even though the on-prem takes some time to move to the cloud. But surrounding that, so that's 35 billion. That's Databricks' core initial TAM for Lakehouse. Then surrounding that, you've got a number of other things. You've got data integration and ELT, ETL. That's high single digits billions. You've got some things around real-time data and that Delta Live tables, which is their stream processing and live ETL offering is going after, sitting on top of Lakehouse again. So that's multiple billion. That's kind of more like Confluence market, and that's growing extremely fast. Though you often use Confluent Kafka in tandem with Databricks, for example. And then around that, you have a lot of the BI and reporting, as well as AI and ML analysis, what people will pay for the Databricks workspace, for example. So that's at least another 10, 15 billion. It all comes to about 50 billion today and growing pretty fast. The big question from there is just, how big does that get? As software in the previous era was capturing CapEx, basically, and sat at around 3% of global GDP all in, we see that expanding pretty significantly at Octahedron, and actually think that basically modern cloud data infrastructure and Databricks' TAM can more than 4x as a percent of GDP this decade as we start to capture a little bit of OpEx. You had 100 engineers working on this project. Now, if they all have GitHub Copilot X and are going 40% faster, you might have 80 or 70 or 60. And so some of that budget goes to the Databricks and the cloud providers of the world. So the question beyond that is, how big does that piece get? You see all types of forecasts for AI and machine learning native applications on top of that go a lot bigger. The last big piece is something that hasn't happened yet, but we're seeing hints on the horizon with Snowflake Unistore, which hopefully we'll finally see in public preview sometime in the next 6 months, which is extremely exciting. And if Databricks ever thinks about something in that direction, which seems likely on a 5-year term, right? They both start to move in that direction. That's an entire another $50-$55 billion TAM, right? So you're doubling it right there. So you've easily got 100 plus. And then the question is how much you do around that on monitoring. They're already doing a lot on observability and monitoring and data lineage and real-time data and all of that.
Is there sort of just like a steady state? Like obviously everyone says, hey, GDP. So, TAM just grows with GDP, but I'm assuming like part of the steady state growth above GDP is also just associated with data is just growing fast and it's usage based. I don't know what that number is. No one knows per se, but like there's some sort of steady state level that's still going to be much higher than GDP. Is that the right way to kind of think about it? Or
Yeah, absolutely. And on top of that, we've got, clearly Databricks and Snowflake are playing in the cloud first and really cloud only multi-cloud world. And so that's obviously growing much faster than the overall market as well. So the cloud native portion or cloud-based portion of each of these markets is a portion of it and is growing relatively fast.
Yeah. So now we get into some of the juicy stuff. So first, let's paint out the competitive landscape. And obviously, we've mentioned Snowflake a number of times. We have some questions where we want to get into that a little bit deeper, but there's other competitors, right, out there. What's the competitive landscape look like?
So the big one clearly is Snowflake, as well as the cloud provider's own offerings, which let's table that for just a second. In Databricks' original business, which is that data science workspace, as well with Spark runtimes and all of that, there are a couple competitors worth noting, both of which Snowflake has invested in. So Dataiku and DataRobot. And they have some level of overlap. They really came from a little bit different areas. So DataRobot came from kind of where I started in this whole data science world, which is basically your standard Kaggle competition data scientists running some of these off-the-shelf machine learning and predictive models and all of that, right? And trying to optimize everything. And their original CEO and co-founder, Jeremy, was a Kaggle grandmaster at one point, right? So they started with that, and they were basically doing a low-code, no-code version of a lot of these somewhat more predictable scikit-learn models and such that you can run. You can get to 80% accuracy or so, 75%, just by basically running them as is off the shelf with the parameters the way they start with, right? And then make some adjustments. So in a visual interface, someone who doesn't know how to code, doesn't know any Python, trying to just do a basic, can we figure out a fraud detection model type of thing. Obviously, it's nice to get to that 75, 80%, but getting to, selling to Capital One or something takes a lot more than that. And so they expanded, and over time, they started to move into this kind of offering notebooks with Zeppelin and some of this moving towards where Databricks is. Done relatively well. Databricks continues to outperform all of these players by a good margin. The other is Dataiku, which started in Paris. It's coming from a little bit of that angle, but a more of somewhere between Databricks and Alteryx, as in it's more friendly for business analyst types who are trying to do some data science work, a little bit of like machine learning work, and trying to help make that more streamlined. These are both much smaller companies, but they are part of the Snowflake ecosystem. And sometimes people will use both DataRobot and Databricks within the same company, for example. But Databricks, while it's expanding to business analysts and those companies' core customers, is really, it started from, and its bread and butter still is, a lot of people who can write some level of Python and actually do some data engineering and data science and such. Then the next big one, obviously, is Snowflake and the cloud providers.
Those are the ones that everyone's going to talk about. So the cloud providers are not dummies. They're pretty smart. They've shipped it. By all accounts, a lot of people really love BigQuery, Google's offering, and use it and talk about using it for ML use cases and things like that. So how do you think about this landscape? Like, is it Databricks and Snowflake are in a class of their own, and then, oh, hey, they're all just taking share from the cloud providers? Like, are the cloud providers still major competitors here? And are they someone that you're watching? Like, if we narrow it down, I know there's a lot, but if we narrow it down to 5, right, those 5, the 3 cloud providers and Databricks and Snowflake, like, how do you think about that?
The first thing is the cloud providers. And one really important thing here is Databricks does have a big advantage. And maybe we can come back to this in a second, but basically, unlike some of the other providers, a Snowflake or a Confluent, which are passing through the cloud costs, which are essentially eating the cloud costs themselves, right? It flows through to them, their margins, and they're going to AWS, or they're going, in Snowflake's case, or Azure or others, and trying to negotiate their own cloud bill down, because that improves their margins in what they sell to customers. Databricks is the opposite in that it passes through the costs. So I've actually got a Databricks bill here, and then I've got an AWS bill alongside of it saying the things that ran my Databricks instances. What is the AWS bill for that? And of course, they optimize all of that to the utmost on cost and everything. But what that means is a lot of their go-to-market is really in parallel with the cloud providers, and both sides have incentives to promote Databricks. So for example, with Azure Databricks, it's a first-party offering on Microsoft, and even Satya Nadella has said he himself thinks about it as Azure Databricks as part of Azure, essentially, right? And it has that placement and partnership agreement. On AWS, if you talk to sales reps there, you get a lot of important pieces of color, which are the opposite of a Snowflake, for example, which is negotiating almost against us to try and get their cloud bill down and improve their margins. With Databricks, we actually have incentives to sell more Databricks, and they have incentives to sell more of us, because every Databricks service, if you are using Delta Lake and Lakehouse for storage, that's going to be stored in Amazon S3, for example. And so that drives more money to Amazon on S3. If I'm running more analyses in Databricks workspace, ML workspace, that's all going to be running on probably EC2 instances, often with a GPU. And so that drives more AWS usage as well. So there's this whole alignment. And so that's the first big thing, is the cloud providers are partially on their side, and you have this really unique go-to-market. But if we table that, of course, they all launch their own offerings in all of these spaces, and they have things competing in Redshift and competes with Databricks SQL, and BigQuery competes with everything. And so that's always a reality. We do see there's always going to be some 10, 20% of the market, depending on the cloud provider, that's often somewhat less savvy, or newer startups or SMBs, or people who don't have elite data engineers to put this all together themselves, or compare specs, which are much better for Databricks and to some extent Snowflake. And they'll just use the AWS version, or they'll use the Azure version. That's mixed with AWS, but the big one is actually BigQuery. We're seeing excellent adoption alongside Snowflake and Databricks. And so I really narrow it down to those three. If Google Cloud was as big as AWS, that would be a very serious threat. Even, for example, Wayfair, which used to build all this themselves as an elite team, now moved mainly to BigQuery, for example. The last big one is obviously Snowflake, and that's really the main competitor here. Ultimately, Databricks and Snowflake are going increasingly head-to-head to take all of this. First, that 35 plus 1020, so 50 billion plus TAM in the OLAP side, and eventually probably this whole additional $55 billion TAM on the OLTP side. They're coming from opposite side of the world. Databricks from the engineering and data scientists and AI engineer side of the world, and moving over towards your Snowflake business analytics side of the world. Snowflake coming from your business analysts writing basic SQL queries, sending it to a dashboard for your sales team. And they're both moving towards each other's direction. And we really see them both as being the two dominant players for the next few years, in that AWS and Azure solutions are much less friendly in terms of being multi-cloud and having less lock-in. Google is actually okay here on BigQuery and such, but they're smaller. And so really the big two providers are Databricks and Snowflake on multi-cloud infrastructure, optimizing everything across the different clouds, et cetera. And they're on a increasing collision course.
I mean, that is for sure, right? Because it seems like Snowflake ships native apps or something like that, I think it was called, and then Lakehouse apps comes out, and then Databricks ships something, and then Snowflake comes out with Snowpark, which is their Python workflows, and it's very much this head-to-head convergence. I got to be honest, it seems like a lot of the marketing too is almost geared to those two, right? This is the battle of the titans or something like that. But then the cloud providers are not there. I wonder if that's almost done on purpose, where it's at least if two of us are the core atomics, like, don't worry about these massive companies doing their thing. We're innovating first. We're pushing everything forward, and they're kind of following us.
There's definitely at least an element of these two subtweeting each other occasionally in some of their marketing. And the conference conflict actually was happenstance this year, but in a lot of other areas. The bigger thing with the cloud providers is really, and BigQuery is a real consideration in all of these RFPs, which Databricks' Lakehouse is now winning more and more of, actually, even versus Snowflake in the past year. But at least for AWS and Azure before this year, through 2022, the performance difference was pretty pronounced. And even a medium small enterprise can at least run some comparisons and find, okay, Databricks Lakehouse is going to be cheaper for a whole bunch of the workloads. And so even what we saw, for example, in the last year, a lot of before it was winning RFPs outright versus some of these other players, was a lot of the larger, especially tech companies, somewhat savvy companies would say, okay, we're doing lots of AI machine learning work. Can we look at our top 5 to 10% of workloads by number, which actually make up 30 or 40% of our costs? These are our big models that we're training, our large language models as well, that are extremely costly. And now that we're finding these workloads or this thing to be much more cost efficient on Databricks, maybe half as much, maybe a fourth as much, if you really tune it to the utmost, a tenth as much as a Snowflake, we're going to move that set of workloads for that 30% of our cost base to Databricks Lakehouse. And then the other 60, 70% of cost, which is 95% of workloads by number, we're going to keep running on Snowflake or BigQuery, what we have. So the performance has been pretty different, and that's told its own story.
Okay. Regardless of certain customers and marketing that has happened recently and things that have been exchanged regarding a certain IPO recently, but regardless of that, like when you're doing your customer work and you're talking to folks, can Snowflake and Databricks coexist together?
For now, absolutely yes. And the short answer is they came from coexisting together. They were partners in, even when we first invested 3 years ago, a very common data stack was you use Snowflake for your business data side and your SQL dashboards, querying and dashboards, and your data science ML team and AI team uses Databricks to run things off your Lakehouse and train all these models, right? And you had just these two totally separate redundant data architectures, and then people would connect Snowflake to Databricks and vice versa. You still see plenty of that, but now that Lakehouse is becoming much more dominant, they're both going to survive and do extremely well in the market. And we see them becoming the two biggest players, even with the cloud providers in there. But one of the biggest differences is in the positioning around how they interface with others. Snowflake has a semi-open ecosystem in that it plays well with Dataiku and Data Robot and Elation on the catalog side and its own offerings like Streamlit, but it's still a somewhat closed ecosystem. They're taking a bit more of an Apple approach and abstracting away any complexity and any optimizations you can do in tuning of performance. So it's made for more business analyst types. And Databricks, on the other hand, has a lot more you can do around that. And so over time, it seems like even though they'll be on this increasing collision course, a lot of the open source world and semi-open source friendly world and the tech world will favor Databricks to an extent, right? Because you can play extremely well with, I can use Lakehouse and then I can use Presto on top for querying instead of Databricks' query engine, which has better performance, and work with all my other data sources, right? Versus if I use Snowflake, I'm locked into these pretty high costs to some extent, not as bad as 20 years ago, but it's a much more closed ecosystem. So a lot of it depends on the ethos of the developers at the company you're working with.
I will say it is cool to see, Snowflake in public earnings has said they're going to take a hit to revenue because they're pushing through optimizations on the compute and storage side. And it's really cool to see. That's what AWS in the early days used to do, right? It would always be like, here's the price decrease and stuff like that. And that certainly has gone away in recent years. That you don't.
For some of their products, for sure. For their basics like EC2, they still talk about that a lot, yes. Right? So it's nice to see some of that from Snowflake as well.
Yeah. I want to move a bit into the business model. We already covered the cloud go-to-market, but in terms of just the revenue sources, is it all subscription ARR? Is there a services component to it as well? Like, how do you think about that? And then is it usage-based? Is it a different type of pricing model? What is kind of under the hood?
Yeah, so about 2.5 years ago, Databricks moved to a completely consumption-based, usage-based pricing model. And so they use a unit called a DBU to track how much usage you put in. And you have a couple categories. One is for heavier tasks, like if I'm training a larger model or a large language model, those are a little more expensive. Then you have one called jobs DBUs, which is for your regular running pipelines that are constantly going, feeding into your commercial product, et cetera. And those are a little lower. But it's all completely aligned with usage at this point. On the services versus subscription side, it's almost all subscription. They haven't shared this publicly, but you can think of it broadly like some of these other names we talk about, a Confluent or a Snowflake, in terms of kind of low single digit services to help everything go along as well.
Is there a channel partnership ecosystem around it? Like, for example, Salesforce, at this point now, they have a services line item, right? But at the same time, they're using the distribution of Accenture and Deloitte and so on and so forth to do that. Is that something similar that you see Databricks doing as well?
This has been huge in the past year or two. And The quick version of their entire go-to-market was, of course, it started with this kind of bottom-up developer-led go-to-market we talked about, and organic rise within a company. Then they added, over the past few years, this strong top-down go-to-market, brought in some of the best people from Salesforce and ServiceNow and all these sales organizations. And that's working extremely well now, selling to CIOs, especially in this LLM era where people are coming in and joining a regular sales meeting. A CIO is joining and saying, okay, Databricks, how should we set up our entire data architecture for this LLM era? Which, thankfully, in their case, the short answer of that is basically everything in the Databricks Lakehouse is kind of optimized going back a few years for this entire era. And more recently, all of that is still so new that they started building out a lot of the channel partnerships, the partnerships with the Accentures of the world and the co-selling and services partnerships. And those have been absolutely on fire in the past year. But if you look back 3-4 years ago, those were non-existent. Now they're really potent and powerful sales channels, as well as helping in government and federal sales and all sorts of things. But for example, we've talked about this in the last few meetings with Databricks, and they show some amazing stats, which are just, because services is such a small portion of their business, they're basically a pure SaaS and PaaS, completely cloud-based solution. They're just giving all this services business to the Accentures of the world. And so they're actually creating a multiple of this 1.5 billion in annualized revenue run rate that Databricks has, growing 50+% and accelerating. The Accentures and Capgeminis and all this of the world are getting a multiple of that. So it's a win-win for all of them. And the numbers you see coming out of some of those groups are phenomenal on this sales piece, especially in the LLM era.
I want to move into the kind of future, right? Because there's some really exciting stuff that's happened. You mentioned Databricks seems very well positioned for the AI LLM world, but I want to go into the particulars. And so are LLMs that next major tailwind for Databricks? And if so, why?
Yes, they are, in that they accelerate a lot of things. And you'll probably see this in the IPO numbers once we get there for the next few quarters. But they're also an integral part of everything Databricks already does. It's like they saw it 4 or 5 years ahead of time, which basically they did on a lot of these things, the problems they were solving, and built this stuff for things that people are going to need in the future, which is starting to be now. And so a lot of this is tailor-made in really interesting ways. And LLMs are a huge catalyst, but they fit into, you're still doing a lot of the work in the Databricks workspace, running off of Databricks Lakehouse and through Delta Lake when you query your data, for example. And so it all fits together extremely nicely. A couple big pieces here that are really important are, first off, where did Databricks come from? Even if you talk to them or Ben Horowitz or others around their founding story, or you look at their early decks, a couple of which are public, we can post below the podcast. Their story from day one was AI and machine learning, the entire analytical data infrastructure and your machine learning workspace. And so what they called this at the beginning was the intersection of big data, essentially working with massive amounts of data that are too big to store in one place if you're a Netflix or a Wayfair or a Instacart. So that needed wholly new infrastructure, which is the Sparks and the everything coming out of the Hadoop ecosystem and the version 5 of that we're at now with Delta Lake and all the others. Intersection with AI and machine learning work sitting on top of a lot of that. Intersection with everything cloud-based and cloud-native. And everything they've done ever since then has been an evolution of that. And so as a couple important examples in what's already there or already in public preview, we've seen a bunch of things popping up more recently around LLM functionalities. So at their summit this year, they announced a number of really important things, observability and monitoring for Lakehouse, also covering LLMs. We've already seen, for example, in their partnership with Mosaic, which they acquired, the joint efforts of Mosaic and Databricks have already shown up in public preview of a LLM model serving solution, which matched with their AI gateway means, and eventually their marketplace means, I'm going to be able to go into my model registry on Databricks. And for a customer like this already works in public preview today. A customer like us, this already works in public preview today. But I go into my model registry and see, my colleague trained this particular structure of an LLM for a particular use case that's super useful. I want to use it for some other task and data type in my company. So I'm going to take the pre-trained model that this person already spent $1 million training, for example, then I'm going to fine tune it on my new data set. And so I pull that from Databricks Model Registry. I'm probably getting my features on some of the data from a feature store that's in Databricks. My governance goes through Unity Catalog in Databricks, which is now all sorts of friendly for LLMs and prompt engineering and monitoring prompt drift and things like this. I pull the model from the registry into my Databricks workspace, and then I'm fine-tune training it there on probably a Spark cluster run by Databricks with GPUs. And I'm pulling the data that I trained it on from my data lake through Delta Lake and through Databricks Lakehouse. So it all fits together really nicely. And some of these new announcements that are coming out around observability for LLMs, around sending your model out as a REST API so you can use it in commercial use cases, are already happening. And we're seeing the AI-based assistant pop up, for example, which has been really helpful. So that's the first big piece, is all their existing infrastructure is already LLM ready. And the few pieces that aren't already in the existing product. So for example, vector search and vector database, something they announced in June. It's now in private preview. We'll probably be able to use it in the next few months, and then it should be out early next year at the latest, right? And so while if I'm working with an LLM now, I'm working in a Databricks notebook, but I'm working with Chroma in terms of where all my embeddings are stored and where I'm calling them from for retrieval augmented generation. But as soon as Databricks vector search and vector database is good enough, like everything else that's integrated in the product, and I've done this with so many other things, I'll probably move to that and just use that for more products. So all that fits together really nicely. The last big thing is some of the announcements they made on what is the next big move for Databricks and the future of all of this, even beyond that $50, $100 billion TAM, which gets at some things they've been working on for multiple years. And the short version of this is, instead of me having to write everything in Python code and having great data engineers set all the infrastructure up and all of this, even on Databricks where they make it easier to use, or Snowflake, the future is starting to move towards text to SQL, and ultimately our business analysts being able to write basically English natural language queries about, okay, get me this data from these different places, and it has the setup ready to do that efficiently, and then do this analysis, or what do you find in this particular subset or slice of the data, right? So basically everybody working with data and doing some AI ML analysis or potentially training basic models, all in English for the most part, very low code or no code type of thing. And so Databricks has actually been working on this for a number of years. Matej, who's the co-founder alongside CEO Ali, Matej led a team at Stanford that was leading a lot of, in academia, things that have turned into this LLM-based search and indexing and retrieval across all of your documents, across all of your business data. When you think of a Glean or some of these companies working on this, or Google has their internal vision that now they're selling. So they were going back 3-4+ years building cutting edge solutions on all of this in academia. Now we see this spilling into Google, into Bing, and all of this. But a lot of that moved into a few products they're working on now. The big one that unifies a lot of this is called Lakehouse IQ. They announced in June. And that's basically moving beyond text to SQL with LLMs and straight to natural language querying of, okay, find me this data, do this with it, and then run this analysis for me. And so that in the long term dramatically expands the TAM potentially and makes things accessible to not only Snowflake's bread and butter business analyst users, but many more people. And that's really the long term of where they're going, that we're actually already starting to see pop up in the product with surprisingly good performance. So we'll see how the next year goes.
It's pretty crazy that the TAM continues to expand at such a rapid cadence. Snowflake is free cash flow positive and actually meaningfully so at very impressive margins. Do you worry at all about, Databricks is not and is spending a ton on growth? Now, obviously they're expanding TAM and they're shipping out some really exciting products, but how do you think about that, right? Where Snowflake's really showing really impressive free cash flow margins and then Databricks is still spending quite rapidly.
It's definitely a real thing. Medium term and long term, my answer on the medium term and long term is no. They're making the absolute right investments. And unlike essentially any other company at that scale that we know, a huge portion of these investments are turning into commercial products that are equal to or better than best in class performance and adding billions of dollars of TAM for things like, going back a year or two, feature store, but more recently, a lot around live streaming, a lot around this Lakehouse IQ, all these different things. It's not like they're investing badly. They're investing better than almost any company I can name in the entire world. And so it all plays out over a 5-10 year term. They are TAM expanders by definition, more than almost any company we know in the world. They're certainly in the top 2 or 3. So medium term and long term, they're making all the right moves. They're investing a lot in R&D. They're still bringing in the absolute best in class engineers and go-to-market people at both senior level and junior 22-year-old grads coming out of Carnegie Mellon and Stanford and all of that. And so that long-term piece I'm much more confident on. In the short term, of course, there's a reality that Snowflake is just raised its long-term FCF margins from 25 to 27% because it's already there, basically, right? And so they're immensely cash flow generating, whereas Databricks said enough in its PR around the last round that we're going to invest hundreds of millions of dollars more. They're taking the most aggressive path, which means, as best we can see it, they have a very good chance to eclipse Snowflake and others in terms of total value captured over the next few years. They're about a year or 14 months behind Snow on revenue now. However, they're about 2 years behind on free cash flows. And so if you were public today, or let's say if you were public in July 2022, a year ago, when people were really focused on Rule of 40 and efficiency and profitability, they would have been penalized to some extent. We saw Confluent, HashiCorp, some of these companies that are great companies get penalized for that. And so they probably wouldn't have gotten Snowflake's 25 plus X EV to gross profit multiple. Today, they'd probably get close and they'd trade at about the level of their last round, maybe higher with some AI hype. They'd get dinged a little bit on the profitability, but obviously they're doing a lot more things around everything they do is made for this next era of software that gives some additional level of confidence. By the time they go public, let's call it, they are IPO ready now. They could go public right now, but let's call it mid next summer or something. By that time, you already have an outlook to you've improved bottom line margins for a few quarters and you have a clear outlook towards profitability that even though they won't be where Snowflake is then, it should be much less of an issue. And so time helps this whole question.
We just laid out the bull case, right? Everything's going really well, but there's always risk. And obviously, one, I think, is valuation. But what other risks should we be aware of outside of capital markets risk or funding risk or things like that, or interest rate risk, right? All that sort of stuff. Those are always a concern. But like specific to the business that the business can control, what are risks that you worry about or that one may worry about?
There are definitely a couple big ones. The nice answer to this is they are squashing all of their risks like I've never seen any company do. And as a just quick example, a lot of the things we asked Ali and the team about in our first few meetings going back 3+ years were on some of these competitive threats. What happens as the world moves to much more of a streaming-centric infrastructure, right? Where Kafka governs everything. And maybe instead of then going to Databricks, a lot of what Confluent's doing with stream processing and Apache Flink and all of that starts to take more value across the value chain. Areas like that. And we had 10 or 12 of them, right? Another one was, for example, in the beginning, before they launched all of this serverless, much stronger performance, abstracted away complexity, moving towards Snowflake-like model, it was a little more for people who could code than people who could not code. There was some complexity. That's dramatically improved. And now the workspace is much cleaner and you get to see everything you're doing. All of these issues, each time we would bring it up to them, the live streaming, real-time streaming data issue, everything, we'd bring up maybe 5 or 10 a meeting, and they would already have launched all of it basically in either beta internally or private preview. And so then Delta Lab tables came out 2-3 months later in public preview and things like that. And they've done that with 2 or 3 dozen major things, major multi-billion dollars of market cap and EV type of things so far. And so they've taken a lot of those away. And the short answer for our biggest thesis on them in bull case is a comprehensive term we talk about that we call software velocity, which is everything from taking, in their case, the cutting edge academic research, turning it into massive open source projects with 500 million plus and nearly 1 billion downloads a year in their top 2 projects, and then commercializing them, scaling them up, go to market, this whole cycle, and churning out new features and products that are best in class at a best in world rate. And so that's put away a lot of their risks. But if you were to summarize the big couple risks now, it's a related one on the first one, which is in the data and AI era that Databricks is creating and working in, We're seeing faster disruption cycles, more companies and open source projects spring up every day and grow it with rapid adoption and functionality that improves. And so we're seeing threats come up and scale at a much faster rate to take away parts of your value. We're seeing them eat away at parts of AWS and Azure and everybody else. So this is a threat to everyone in the industry. Mitigating that is the fact that Databricks is arguably the number one company in all of late stage and public market software in terms of this concept we call software velocity, right? And that means that they're actually turning out the best in class products that are disrupting themselves and disrupting others so far. But if you fast forward in a long term in this faster disruption cycle, high risk industry where nobody has a perfect moat, eventually, maybe for Databricks, it's 10, 15 years down the line, everyone gets an innovator's dilemma type of scenario where one of your existing revenue pools is too big. So very confident in the rest of the decade for them, but on a 15-year term, that's certainly number one. Number two is in this new LLM era, how much value gets pulled away to some extent by this kind of entire new computing stack we're seeing spring up, where OpenAI maybe owns the entire API layer and development layer, where companies like Chroma or others maybe own the database layer, or maybe that's eventually pulled into some unified offering like MongoDB is trying to do, right, with its vector search and vector database offering. And you have a lot more of the queries, for example, in natural language from people who don't know how to code. In theory, that could all replace a lot of what Databricks or Snowflake is doing now. And so that's something we have to watch for very carefully, is this entire new computing stack. Again, thankfully, Databricks is launching all of these things and actually creating half of this entire new stack. And so that helps a lot, at least in the next few years and rest of this decade. Third is just there's always, even if you have this strong alignment with co-selling and all of this and aligned incentives on the more Databricks I sell, the more AWS I sell and vice versa. So everyone promotes each other. Even with this, cloud providers are always an existential threat to any of these players, right? And so if BigQuery was the size of AWS, that would be a serious problem for all of these players. And so that's always there.
The LLM use case, I mean, I still remember before, I don't know if it was before Llama came out, but I think it might have been, was Dolly was shipped by Databricks. And that was just such a interesting moment, right? Because it was, I forget what the dollar amount was, but it was a couple $100 to train this model that actually performed really well. And to your point on that LLM risk, yes, of course, there may be risk, but at the same time, if they're able to ship those sort of parameter models at that cost rate for various use cases, that's not a bad position to be in.
And on that front, what's exciting about a lot of what we just talked about on the LLM infrastructure front is all these needs for the new era, whether that be monitoring prompt drift, all that stuff, fine-tuning LLMs, pre-training LLMs, is they have a whole bunch of offerings around that. You know, Dolly was super interesting around the era of Stanford Alpaca because it was, from an academic standpoint, because they spent this minimal amount of money and just had a very well put together data set that a lot of Databricks engineers worked on that made this model, after you trained it and fine-tuned trained it, almost as good as Instruct GPT from OpenAI in terms of instruction following tasks on a specific subset of tasks. And since then, so a lot of interesting things they're doing internally. They're working on their own large language models and research around there, of course, because Matei and others have led this for the past few years and literally wrote all the papers, not all, but a handful of them on each of these things. And now they have their own work that's going along. They have Mosaic as well. So Mosaic's MPT models, MPT-7B, are extremely robust. Not quite GPT-4, but they're always among the most used models on Hugging Face communities and all of that. And so we have that. I'd say watch out for their next generation of models is going to be really interesting. So you have that internal kind of 1P type of approach. At the same time, you have Databricks' whole core advantage, which is they are open first everything. In terms of the developer ecosystem and everything they built. They built these massive multi-100 million downloads a year open source projects, and that's still their whole core ethos. And so they also already are working with a number of, they have Llama 2, where you can bring in through their model serving solution and models from Anthropic and all the others, and are already have rolled out the vast majority of what Amazon is hoping to do with AWS Bedrock and all of this. So that mix of the best of open source and the best of your own top tier researchers and engineers output combined all in one place with central governance, And everything in this new era is extremely important, especially once you extend into this Lakehouse IQ era where everyone's trying to build a chatbot. Everyone's trying to build something like this Lakehouse IQ. Snowflake acquired Neva, which is an excellent team. The difference in this case is a lot of them don't have all the information they need to do this at world class. Databricks does. It owns the entire data catalog, so it knows who has permissions for everything. It has all the metadata through Delta Lake, the statistics on your data, the indexes to reach everything easily. And so it has all this information that makes this kind of querying and asking English questions of your data a lot more doable on the underlying Lakehouse IQ type of infrastructure, because you actually have these filters you can push down in terms of making everything more efficient and finding out what you need to find out. So a lot of exciting things where they can go from here. But that whole best of open source plus best of internal matchup is exciting in everything they do.
Well, Chris, that was a tour de force on everything Databricks, and thank you so much for taking the time. Is there anything that you'd like to highlight for Octahedron coming up? I will put in my own note, which is I think it's called A Few Things We Learned, that comes out each quarter. I imagine one probably just came out or is coming out soon or whatever, but it is one of my favorite reads. I really enjoy it. They are quite long. That's the only thing I'll say. I need a ChatGPT summarization of it, but it's amazing content. So thanks for you guys and the team for putting that out.
We've already done a couple of experiments on exactly what you're talking about to see what we can do there in Databricks notebooks, interestingly, right? And so, yeah, definitely are a few things we learned for the July to September quarter just came out, has some good tidbits on Databricks and Snowflake and all of that. The bigger thing I would say is, number one, use Databricks if you're doing work in any of these areas, and try a bunch of their things out. Keep an eye out for, it's going to be a really exciting next 6 to 9 months that really shape the entire industry just from what Databricks is doing alone, not to mention all the others. And so it'll be fun.
Well, looking forward to it. All right. Thanks, Chris.
Thanks so much for having me, Shomik. Cheers.